Okay, in this video, we're going to show analytic methods to visit some linear motion problems. First problem is we have a velocity equation 10 minus 2t of a particle moving along the x-axis from t equals 0 to t equals 9. First thing we want to determine is when the particle is moving to the right, to the left, and stopped. It's moving to the right when v of t is greater than 0. That's when 10 minus 2t is greater than 0, which means 2t would be less than 10, t less than 5. But t also has to be greater than 0 because of the interval given, so it's moving right when t is between 0 and 5 seconds. It's moving left when v of t is less than 0, or 10 minus 2t is less than 0. That means that 2t would be greater than 10, and t would be greater than 5 and less than 9 seconds because of the interval from 0 to 9. The particle is stopped when v of t is equal to 0. So 10 minus 2t equals 0 when 2t equals 10 and t equals 5. So the particle is stopped when t equals 5 seconds. In part B, we're going to find the particle's displacement for the given time interval. If you recall, the integral from a to b of v of t dt would equal, taking the antiderivative would be s, and using the fundamental theorem of calculus, s of b minus s of a. That's final position minus initial position, and that is displacement. So we're going to take the integral from 0 to 9 of 10 minus 2t dt to get the displacement. That'll be 10t minus t squared from 0 to 9. That'll be 90 minus 81 minus 0 minus 0. So our displacement will be 9 meters. That means the particle will be 9 meters to the right of where it started. In part C, we want to find the particle's final position. They give us the initial position of 3 meters. We know that the final position minus initial position equals the displacement. Solving for final position and taking the initial to the other side, final position equals initial position plus the displacement. So the final position would equal the initial position of 3 plus the displacement, which is the integral from 0 to 9 of 10 minus 2t dt. So we get 3 plus the antiderivative gives us 10t minus t squared, evaluating it from 0 to 9, which gives us 3 plus, plugging in the 9, 90 minus 81, minus plugging in the 0, 0 minus 0, which gives us 3 plus 9, or a final position of 12 meters. In the last part of this problem, we are going to find the total distance traveled by the particle. So the total distance will equal the integral from 0 to 9 of the absolute value of 10 minus 2t dt, so that we don't end up with any negative area for the area between the curve and the x-axis down here. Absolute value will flip this part of the curve up over the x-axis, so everything we get will be positive, and we'll get the total distance traveled, the distance traveled to the right and the distance traveled to the left. So we'll take the integral from 0 to 5 of 10 minus 2t dt, which will be the area above the curve. That's when 10 minus 2t is positive. We had already found that out earlier. Minus the integral from 5 to 9 of 10 minus 2t dt, which gives you the area between the curve and the x-axis from 5 to 9. That, when you do that integral, it'll be a negative value. So by subtracting it, minus the negative turns it into a positive, and you'll be adding everything up. So we have the antiderivative evaluated from 0 to 5 minus the antiderivative evaluated from 5 to 9. Evaluating it gives us 50 minus 25 minus 0 minus the quantity 90 minus 81 minus 50 minus 25. That then gives us 25 minus 0 minus, this will be 9 minus 25, which is negative 16. So we have 25 minus a negative 16, which is 25 plus 16. And the total distance traveled of this particle will be 41 meters.